So this part of the video is just for A-level students. It doesn't actually come up on the AS spec, so you don't need to know it. So at A-level, they could ask you to do multiple transformations onto one graph. Now this isn't too bad in my opinion. You just need to do it in the correct order to do it properly. It's quite a logical order in my opinion. So they're never going to ask for 4 transformations in one, but I think this is the best way to illustrate this, the steps. So let's pretend you have to sketch y is equal to f of x, and then they ask you to sketch y is equal to AF BX plus C plus D. And this is all the transformations that we've met, where we've got the 2 stretches inside and outside, and remember these are also the mirror-ins if A and B is negative, and then it's going to be the 2 translations here, inside and outside the function. So the correct order to do this is you basically just do it in the order in which x will be affected, and whatever you just do, whatever affects x first is first, and then whatever affects x second is second, etc, etc. So in this example, the first transformation that you would apply is b, because that is the first thing that affects x, because it is the coefficient of x. And if b is negative and it's a mirror, it doesn't matter, the stretch is still the same, it doesn't matter, so just times it by squeeze it, because it's inside the bracket, squeeze it by a factor of b. Even if b is negative, the effect will still be the same. And then the second step is the plus c, because this is the second thing that will affect x, because it's inside the bracket. And then the third thing that you're going to do is the stretch here, because this is the next thing that's going to affect x. And the fourth thing that you're going to do finally is the translation outside the function, because this is the thing that is going to affect x last. Okay, now let's sketch y is equal to minus f of x plus 3. So the first thing we want to do, because its coefficient, is to mirror it in the x-axis. So the y-intercept is going to become 1, and it's going to be put here. And you can sketch this in your head if you want to realise what this is going to do. It's going to be a reflection. But then we want a plus 3 for the translation in the y direction. So the y-intercept is now going to become, it's going to go from 1 to 4. And then we can sketch it from this. Remember that it's going to be a reflection, but now the roots are going to be different, unlike if you're just mirroring. So if we sketch this, it's going to look something like this. And like this. If I draw that a tiny bit straighter, with a different root here, and then it coming out like this, and then the y-intercept is going to be 4. I remember to label this as y is equal to minus f of x plus 3. Remember that the turning point, it needs to be symmetrical, because it's for quadratic, it's the midpoint of the roots, and the roots are still going to be minus a and a. They're still going to be the same roots, just positive and negative, because that part hasn't changed from here. And then the new equation is just going to be applying 2 of the transformations, so it's going to be minus x plus 1, x minus 1, plus 3, where the plus 3 is not going to be affected by the minus, because we do that afterwards. And then this is another example where we should find the new roots, because it's a quadratic, so it's not too bad. So to find these 2 roots here, we just make it equal to 0. So we do 0 is equal to minus x plus 1, x minus 1 plus 3. So minus 3 is equal to minus x plus 1, x minus 1. So 3 is equal to x plus 1, x minus 1, and we can expand this to make 3 is equal to x squared. This is actually a difference of 2 squares. It's going to be plus x minus x, so it's going to be minus 1. You can write out the whole bracket if you want to though, to make it simpler. And then it's going to be 4 is equal to x squared, so x is equal to plus or minus 2, which is the answer that we're expecting it to be, because we're still expecting it to be the plus and the minus of the same number. So this is going to be minus 2, and this is going to be 2. And once again, I would say this is definitely an example that is easy enough, in which they would expect you to draw the roots. Really quick, there's a few examples of this in the book, and I think I've seen them ask this in an exam before. The examiners could think that they're really hard, and they could actually make y not the subject, so they could write it in the form 2y plus 1 is equal to f of x, and they will ask you to sketch this. Well, the way that you just sketch this is you just make y the subject, so you're going to say 2y is equal to f of x minus 1, and then y is equal to half of f of x minus a half, because you're going to have to divide that by 2 as well. So if you sketch this graph, the first thing that you're going to do is do the stretch here, where it's outside the brackets. It's just going to work the way you'd expect it to. So the y-intercept is going to be halved to minus 0.5, which will be somewhere about here. And then we're going to apply the transformation minus a half. So it's going to move the y-intercept back down to here, like this. It's going to move it back down here, back to minus 1. But the effect of the squeeze from the half is still going to be present, to the fact that if you think about it, if you sketch this previous graph here, it's going to look like this. So if we actually move this down by a half, what's actually going to happen is the roots are going to become bigger. So if we sketch this, it is going to look like this. Let me just draw through the label, if that's okay. And like this. We draw that a tiny bit straighter. Draw it like this. And like this. Here. That's going to be the new transformed quadratic, where the y-intercept is the same, but we've got two roots here. And once again, the roots are just going to be the plus and negative of the same number, as it's still going to be the same here, and it's symmetrical. Remember to label this as 2y plus 1 is equal to f of x, because this is the same line, remember, so you can just label it as this. And the new equation is going to become y is equal to half x plus 1, x minus 1, minus a half. To the y-intercept remains the same, but there's going to be new roots, which again we can figure out if we make y is equal to 0. X minus 1 minus a half, and then bring the half onto the other side to make half equal to half x plus 1. X minus 1, divide both sides by a half to get 1 is equal to x plus 1, x minus 1, which we can simplify again to the difference of two squares as x squared minus 1, and then we're going to say that 2 is equal to x squared, so x is equal to plus or minus the square root of 2. So this root here is going to be minus 2, and this root here is going to be positive 2. Okay, so here's a couple of questions on graph transformation. Sorry about question 1 being so small, you might need to screenshot it and make it a bit bigger if you're on phone or something like that. But anyway, pause the video, have a go, and I'll go through the answers in about 5 seconds. So for question 1, this is an unusual graph that you wouldn't have seen before, but that's not really too important. The important thing is that it's just a transformation question. Okay, so the question gives you a sketch of the equation y is equal to f of x, and then it talks about the points. And then it says, state the coordinates of the turning point on the curve with the equation y is equal to f of x minus 2. So this is the turning point up here, and it wants you to find the coordinates when we apply the transformation f of x minus 2. So remember, it's going to have the opposite effect. It's going to affect the x values when it's inside the function. So what it's going to do is it's going to add 2 to all x values. So the new value of the turning point is going to be 4, 7, and that's the answer. For part B, it wants you to state the solution of the equation f is equal to 2x is equal to 0. What this is saying is it wants you to find the roots, because it's equal to 0. so y is 0. It wants you to find the roots for the transformation f of 2x. Now remember, it's inside the function again, so it's going to have the opposite effect of what you'd expect. So it's going to squeeze the graph. Remember, it's the x value, so it's going to be along the x-axis. It's going to squeeze the graph by 2, or another way of saying this is it's going to divide all the x values by 2. So the new value of the root is going to be this root here, but the x value is going to be divided by 2. So the new root is going to be 5 over 2, 0. So therefore the solution to the equation is going to be 5 over 2, because that is the x value. So that is the solution. For part C, it wants you to state the equation of the asymptote to the curve of the equation y is equal to f of minus x. Now remember that if it's f of minus x, that means it's a reflection in the y-axis. And if you reflect this in the y-axis, you'll actually find that the asymptote is just going to stay the exact same. So the asymptote is still just going to be y is equal to 1. It's not going to change, and that's just the final answer like that. The final question is, given that the line with equation y is equal to k meets the curve y equals fx at only one point, state the possible values for k. So the line with equation y is equal to x is a line that is going to look something like this, where it's going to be a straight horizontal line like that, and you need to find the points where it's only going to meet the curve once. Now there are two possibilities for when this can happen. The first one is at the turning point up here. If you consider the turning point up here, it will only meet it once because it's a turning point, so there's only one value. So therefore you can say that one of the kind of possible times is when k is equal to 7, because it's going to equal the y part of the thing, because it's y is equal to k, and it's a horizontal line. So that is one of the possible times when the line y equals k only meets it once. Any time under this, or most of the times under this, it's going to meet it twice, and anything above this, it's not going to meet it at all. And then another time is when it's down here, because then there is no, because there's an asymptote over here, it doesn't cross that line, it doesn't meet it, so therefore you know that there is always going to be one solution when it's like this. So when is these values? Well, let's consider the asymptote here. So as the asymptote is here, everything up to this is only going to meet it once, because remember, it doesn't cross that line. So this is going to be up to when y is equal to 1. So we can say that k is less than 1, because when k is less than 1, it's only going to meet this point over here, as it doesn't cross the asymptote. The other thing you need to consider, though, is that it never touches the asymptote either. This line will never touch y is equal to 1. It will never actually touch it. That's the definition of an asymptote. Therefore, another point is actually when y is equal to 1. It will touch it over here, but it will never actually touch the curve, because remember, the asymptote doesn't touch the curve. So another possible value is actually when k is equal to 1 as well, so we can put the line underneath the inequality sign. And then this is the answer. It's when k is equal to 7 or k is less than or equal to 1. Note that it doesn't ask you to put it into set notation, so you don't need to. So now for the second question. The key of this is just understanding that it is just f of x is equal to 1 over x, and it just wants you to sketch the graph y is equal to f of x plus 2, this is caused by this down here, and then minus 3, which is caused by this here. So do the order, although the order doesn't really matter here because you still get the same right answer, but a lot of the time if you don't do it in the right order you will get it wrong, so get used to doing it in the order. So we're going to do the x plus 2 first, so this is going to shift the graph left in the x direction, so it's going to minus 2 from all the x values. Remember, it has the opposite effect if it's inside the function. So it's going to move the asymptote that was once here. I'm going to do it in a different colour to make it a bit more clearer. The asymptote that was once here, it's going to move it to, let's say, here, and this is going to become x is equal to minus 2, and the minus 3 is going to move the graph down by 3 in order to move the asymptote that was once here. It's going to move it down to, let's say, about here, and this is equal to y is equal to minus 3 now. And then if you sketch, now you just need to sketch the f of x is equal to 1 over x graph in the translated form. So it's going to look like this here, where this is the minus curve and this is the plus curve. I might draw that a tiny bit more clearer because we don't know what the y-intercept and what the root is going to be yet, and I made it look like it was going to be 0, and I don't know that yet. So now we need to label any points the graph crosses the coordinate axes, and as you can see, we have a root and we have a y-intercept. So we can figure out the root easily, or let's start with the y-intercept. Actually, we can find the y-intercept easily by just making x is equal to 0. So it's going to be y is equal to 1 over 2 minus 3, which is going to be equal to minus 5 over 2. So this point here is going to be minus 5 over 2, this y-intercept here. And we can find the root by making y equal to 0. So we're going to say 0 is equal to 1 over x plus 2 minus 3. So it's 3 is equal to x plus 2 under 1. So 1 over 3 is equal to x plus 2. So x is equal to 1 over 3 minus 2, which is going to be equal to minus 5 over 3. So we can say that this root here is going to be equal to minus 5 over 3. And then this is the final answer with the labelling of the roots. We don't need to actually label the graph or the curve here because we've only got one graph on the actual axes. So that's the end of this video. This is the first chapter in which new content is actually introduced. I hope it wasn't too bad with the cubics and the quartics. It's more just graph sketching, which I just found horrible. A level, I just hated doing it. So hopefully just get enough practice at it and you'll be able to get really smooth with your drawing. Hopefully you're much better at drawing than I am.